Wow, so cool!
Do you know how this phenomenon works?
How does it work?
Let me explain it to you.
Okay.
All this phenomenon is actually due to Fourier Transform.
So what is Fourier Transform?
Now, Fourier Transform can be generalized into this formula over here. But let me explain it further what this formula means.
Okay.
Now, as you can see over here, Fourier Transform basically we are taking a general periodic complex function such as this and breaking it down into simpler sums of cosines and sine waves. Alright? So we can see over here this is the summation formula of the cosine and sines. However, to generalize it further, we use the Fourier Transform formula which takes into account non-discrete values of n and m.
I see. So what has this got to do with our light diffraction?
Aha! Let me explain it to you.
Oh, okay.
Now let us take a look at this one-dimensional grating. Which only has one direction. Now, as light passes through the grating, it will end up at a point on the screen. Now let's just consider one point on the screen, and to find what is the intensity that is on this point of the screen. Now, to do that, we need to sum over all the different intensities that is coming from each part of the grating, from x negative infinity to infinity. Now, we do this over here. Fx refers to the intensity coming from the grating, multiplied by a small distance of the grating delta x. And you can see over here this exponential term actually refers to the phase difference as a result of the distance traveled, this difference in distance traveled by each point of the grating, different points of the grating. Now, let us assume that at the far field, we have theta is sine theta is approximately theta, and then we take the limit of delta x to 0. From that, we can see that it actually becomes an integration. Does this look familiar to you?
Yeah, it's the Fourier Transform.
That is correct. It is the Fourier Transform of the grating. As you can see here.
Then what about our case?
Now, in our case of the laser, we are actually looking at a two-dimensional Fourier Transform of x and y. Now, what engineers do is that they will find the inverse Fourier Transform of the image that they want, which comes out as this array of dots, and they engineer this to be a grating. Now, this grating is what is on your laser.
I see.
And when the light shines through this grating, it undergoes the Fourier Transform and ends up as an image of the arrow.
So are there any practical applications to this?
I'm glad you asked. Now take a look at this dollar bill. Now there's something special about this dollar bill. Let me just take this laser and shine it through this maple leaf.
Wow, the $5 sign.
Yes, that is correct. What is happening over here is that they have put a inverse Fourier transform of this image as a grating on the maple leaf of the Canadian dollar.
Wow, thanks for letting me learn so much today.
You're welcome.